everything we've done with polynomials so far has been either adding or multiplying them. But what if we wanted to go the other way? What if we actually wanted to factor a polynomial? Let me show you what I mean. So let's say I have the polynomial 3x to the third power minus 21x. When I say factor it, I essentially want to break it up into the product of maybe polynomials. It could be a mononomial, which is just one term. And to do that, over here, let's see, we could factor out a 3x here. So if you factor out a 3x, this is equal to 3x times, what's 3x to the third divided by 3x? This is, let me write it this way actually. This is the same thing as 3x times 1 over 3x times 3x to the third minus 21x. Notice 3x times 1 over 3x, I'm not changing the number. This is 3x over 3x. This is 1. But the reason why I picked 3x is because I saw that both of these terms are divisible by 3x. And you're going to see that when I divide both of them by 3x. So this is going to be the same thing as 3x times 3x to the third over 3x minus 21x over 3x. And now this is going to be equal to 3x. What's this first term equal to? The 3's cancel out. X to the third divided by x. We learned in our exponent rules, you could just subtract the exponents there. That's x times x times x divided by x. It's just going to be x times x, or just x squared. So it's going to be this first term here is just going to be an x squared. And then the x's cancel out here. 21 divided by 3 is 7. X squared minus 7. And if you multiply them out, you're going to see you're going to get 3x to the third minus 21x. Now, I went through all of these steps really just to show you exactly what I'm doing. But as we progress, you're going to see that you can, your brain will just automatically say, hey, both of these are divisible by 3x. Let me factor out a 3x and then divide both of these terms by 3x to get x squared minus 7. Let's do another one. Let's say we had 4x to the third plus 10x squared minus 2x. So when I look at this, immediately what pops out is that all of these terms are divisible by 2, and all of them are divisible by x. So let me factor out a 2x. So this is equal to 2x times, and when we factor out a 2x, let's divide each of these terms by 2x. 4x third divided by 2x. 4 divided by 2 is 2. And then x third divided by x is x squared. And then we have plus 10x squared divided by 2x. 10 divided by 2 is 5. X squared divided by x is x. And then finally, negative 2x divided by 2x is just negative 1. And if you want to, if you don't believe me, just multiply this out, distribute the 2x, and you will get exactly this. So all we see, we try to look for something that's divisible into every term. We factor it out. Factoring it out, we put it outside of a parentheses, so to speak, and then we divide each of those terms by that factor. And we did that explicitly up here. Now, you're probably saying, hey, Sal, why are we even worried about doing this? And the answer is it really helps us solve a lot of certain types of polynomial equations. Let me show you what I mean. Let's say we have the polynomial equation 9x squared is equal to 27x. And we want to make sure that we get all of the x's that satisfy this equation. So let me subtract 27x from both sides. So let me subtract 27x from both sides. So I get something that equals 0. And this will be a general trend whenever you're doing polynomial equations. Very oftentimes you will. The left-hand side becomes 9x squared minus 27x. The right-hand side becomes 0. And now over here, we can see that both of these terms are divisible by 9x, right? 27 is divisible by 9, so is 9. And they're both divisible by x. So let's factor out a 9x. So 9x squared divided by 9x is just an x. And then 27x divided by 9x, that's 27, negative 27 over 9 is negative 3. And then the x divided by x is just a 1. So this is 9x times x minus 3. You can multiply it out to verify that these are the same thing, is going to be equal to 0. Now this part is interesting. When I take the product of two numbers and I say they're equal to 0, let me do a little aside here. If I were to tell you that a times b is equal to 0, what does that tell us? That tells us that either a or b or both are 0. At least one of these two have to be 0. Maybe both of them are going to be equal to 0. So we're doing the exact same thing here. We're taking the product. You could view that as a. You could view that as b. We're taking the product of two numbers and saying that that product is equal to 0. So that tells us that either 9x is going to be equal to 0 or x minus 3 is going to be equal to 0. Either of these or both of these are going to equal to 0. This we know how to solve. Divide both sides by 9. You get x is equal to 0. This we know how to solve. Add 3 to both sides. Add 3 to both sides, and you're left with x, because these cancel out, is equal to 3. So this equation here actually had two solutions. X could be 0, and you can verify that. 0 is equal to 0. Or x could be equal to 3. 9 times 9 is the same thing as 27 times 3. And you might have been able to figure that out in your head, but when you do it this way, you make sure that you get all of the solutions to the problem. Let's do one more like this. Let's say I had 4a squared plus a is equal to 0. Once again, we can factor an a out. Both of these terms are divisible by a, so this is the same thing as a times 4a plus 1. Right? When I factor an a out, I take the a out of the parentheses, and then I divide each of these terms by a. And that's going to be equal to 0. So that means either a is equal to 0 or 4a plus 1 is equal to 0. Well, that's one solution right from the get-go. And this one right here, we could subtract 1 from both sides. We get 4a is equal to negative 1. And then we could divide both sides by 4, and we get a is equal to negative 1 over 4. Now, I said that was the last one. Let me do one more, because I want to show you, here I'm factoring and then solving, but I want to show you how useful a factored polynomial is. So I'm going to start with one that's already factored. So say I had x minus 5 times 2x plus 7 times 3x minus 4 is equal to 0. And if you're bored, you can actually multiply these out, and you'll find that you get a third degree polynomial. But if you wanted to solve that being equal to 0, it would be very difficult. But this we're going to see is not too bad. As we said, if we have three numbers, if we have a times b times c equal to 0. That means that at least one of these are 0, maybe more than one. Either a or b or c or some combination of them are equal to 0. So once again, I have three numbers. This could be viewed as an a. This could be viewed as a b. This could be viewed as a c. I'm multiplying them, and they're equal to 0. So that means that either x minus 5 is equal to 0, or 2x plus 7 is equal to 0, or 3x minus 4 is equal to 0, and we can solve each of these independently. Add 5 to both sides of this equation, and you get x is equal to 5. So that's one solution to this equation. Over here, subtract 7 from both sides. You get 2x is equal to negative 7. Divide both sides by 2. You get x is equal to negative 7 over 2. That's another solution. And then finally, add 4 to both sides of this equation. You get 3x is equal to 4. Divide both sides by 3. You get x is equal to 4/3. So this third degree polynomial, if you were to multiply it out, actually had three solutions to that polynomial equaling 0. And we're going to see these are actually called roots of the polynomial, the x values that make that polynomial equal to 0. But hopefully, you've just gotten an appreciation for, one, how to factor a polynomial in this video, and also why it's useful for solving polynomial equations.